As you know, we have two main types of the light for healing. One is diffuse light, and for this light, Nansen 100 years ago used and won the Nobel Prize. And the second type is linear polarized light. This is just 40 years ago, and it is present in previous and also today BIOPTRON devices. As you can see, the difference of organization of the photons. In diffuse light, the organization of electromagnetic and electrical and magnetic property of the light is different than in linear polarized light. However, when we make investigation of the human biomolecules, we found out that should be a different light for use for better influence. And what we find out that the symmetry it's very important rule. That means that organization of the photons and organization of biomolecules electromagnetic property should be the same. In that case, pattern recognition of energy and information will be much better. What we found out that about 85% of biomolecules has one symmetry group, which we in science call icosahedral symmetry group. And we try to find solution how it look like. And on this slide, you can see organization of the photons or electromagnetic waves, like diffuse light, polarized, linear polarized light, and hyperpolarized light. As you can see, on the first, for diffuse light, it's some kind of chaotic organization of the photons. In polarized light, it's very well ordered, but it's plain, actually. And in the third case, you have organization, very well organization, but in a specific way. For better understanding, I will show you just one image that you can easily recognize the hyperpolarized light. This is organization of the sunflower. And this is the reason why sunflower follow the sun, because this is the sensor that try to catch the photons from the sun in property way. And when we discovered this, that organization of photons should be in this way, we try to find how to make a photon generating devices like a sunflower. And we recognize that interaction between photons and electrons should be in specific way. When we investigate the photons, we use the property of Poincare sphere, but when we use electrons, in that case, we need to use Bloch sphere. Between photons and between the electrons should be some material. And we found out this is special material with 60 carbon atoms organized in 12 pentagons and 20 hexagons, and with icosahedral symmetry property. And when light, diffuse light, and electrons interact, and this material molecule C60, what we call, generate a new sphere, what we call Fibonacci sphere. That sphere, energy state of that sphere is 85% compatible with biomolecules property. Energy go through some kind of doors, but this is important that to understand the mechanism of interaction with the light. And this molecule you can find we can say anywhere, because in cosmic dust is full of that material, but that molecule was discovered in 1985 by Crotto and his research team, and we make the image of that molecule 1999, and as you can see, this is left is the stick model of that molecule. In middle is the image of quantum state of that molecule, and the right is STM scanning tunneling microscopy image about that molecule. And you can also see how theory and experiment is the same. The size of that molecule is 1 nanometer. This is very, very small. If you compare 1 millimeter with 1 kilometer, is the same as you compare 1 nanometer with 1 millimeter. And it's a rotate, actually, is twisting very, very, very fast, billion times in a second. And as I mentioned before, is discovered in 1985. The first image done 1992. The first book we published about this molecule in 93, and the first patent, one of the first patent in this field, 1997, and the Nobel Prize was 1996. How we make helpful this molecule for our body. We use diffuse light, like the bulb on the beginning, transform that diffuse light by Brewster mirrors, or using different type of filters that interact linear polarized light with molecule C60 and generate energy state which is compatible with biological biomolecules with 85%. This is device on the beginning, as you can see in our design. It's diffuse light, then linear polarized light, and then hyperpolarized light. But what is special? Why we unique on the market? Because photon come in, but in interaction with molecule C60 is generate exciton. Exciton and photon are coupling and make the polariton. That means the light which acts our body, it's not photonic, it's polaritonic. This is special. Why is special? Because exciton, actually molecule C60, organized photon and exciton in polariton, which is compatible with biological structure, because photon was in the beginning diffuse light, but in the end is organized as hyperpolarized light. And that can happen, for example, for the LED diodes. In that case, the blue light will be the change and be smaller, but the green light will be the higher, that transformation. Also, for all spectra like this in the sun, we can have that property of exciton. And when we found that, we published the paper, but also the people in Max Planck Institute also experimentally find out existence of the exciton of C60 molecule. After that, we consider properties of oscillatory process on the different level of the human body, and we make different devices for use, not only the BIOPTRON, but also eyewears and some creams. On the different levels of human body, we have the different organization and oscillation, and we start from the biomolecules to the tissue, to the organs, and the whole body. Why is that important? It's important, for example, for the wounds. And when we have the wounds, we don't like to have the scar at the end, and should find solution how collagen in basal membrane should oscillate, that the basal membrane will be closed and will not give opportunity to tissue to go from dermis to epidermis and make the scar. That oscillation is perpendicular, and our device, our light, also perpendicular and can regulate that mechanisms. But for the BIOPTRON, we have what we call upper polariton, but for the eyewear, we have a lower polariton. The same mechanism. And we tested our eyewear. We tested our eyewear for different application, using for different type of lights, for the neon, for the LED diodes, for the laptop, for the screen, also for TV, for our phones. And you can see the original light on the left side, and when transform our devices on the right part. And you can see how light is changed from photonic to polaritonic. And also we are tested to influence on our biomolecules like serotonin, melatonin, dopamine, cortisol. And in the beginning, you can see how is the change, but the end, we have actually a regulation of all four of these hormones, neurotransmitters, and other. This is very, very beneficial for our state. I will just say a few words about eyewears, and this is on this slide you have 4 very well brands sunglasses on the market, and as you can see, all that have this solution, and in the field of infrared, and this is not good. Why? Because infrared, if we have more infrared, in that case, we will have the problem with cataract. Our sunglasses, we find solution for our sunglasses that we don't have infrared too much, and this is one of the of the best solution for sunglasses, including also polariton light, because any of sunglasses on the market has that property. More about this, you can read in this book, but also in the special journal, scientific magazine is the Galaxy. And you can inform about our innovation and our unique product on the market. Thank you very much for your attention.